Okay, systems. When we studied in Algebra 1 and 2, we studied systems of linear equations. Sorry, I don't know if I'm recording. We knew there were three types of solutions we could get. We could get one solution. Two lines crossed, we have one solution. We could get no solutions. The parallel lines, there are no solutions. If we have the line that is one line is a multiple of another, we could have infinitely many solutions. That was the sum of it with lines. Now we're going to do nonlinear equations. So looking at this example, we have a circle and a line. So we think about that and we say, well, that could cross twice, it could cross once, it could not cross. So 1, 2, or 0 are our possible options. You always want to look at a problem and say, what am I expecting? Now, we solve the same way we did before. We use substitution or we use elimination. So if you remember, we use substitution generally when one of the equations can be easily solved for one of the variables. So let's just do it. So looking at this, we see that we have A and B equations. I'm going to label them A and B. B is x minus y equals negative 2. I can easily solve it for x. Move the y over. Y minus 2. So we're going to take this and substitute it in for x in the first equation. Substitute A. Let's write the A equation. X squared plus y squared equals 2. You do have to substitute into the other equation. So everywhere there's an x, I'm going to put y minus 2. And I'm just going to work it out. Equals 2. So let's work it out. I'm going to have to FOIL that. Multiply it out and FOIL it. Let's move the 2 over. When I see y squared, any squared term, I think this is going to come down to factoring, right? So first, outer, inner, last. Y squared minus 4y plus 4, and then do the rest. Plus y squared minus 2 equals 0. So add like terms. This becomes 2y squared, so I added those. Then there's only one y term, and then I have 4 and negative 2 left. Plus 2 equals 0. Let's factor out the 2. Okay, we just get rid of the 2. We can get rid of the 2 because look, if we divided both sides by 2, these 2's would cancel to 1 and this would just be 0. So let's move up to the top because we ran out of room there. Now we have a trinomial. Y squared minus 2y plus 1 is 0. I can factor that. What multiplies to 1 but adds to negative 2? So I put the y's here. There is no a greater than 1. And if I had negative 1 and negative 1, they would multiply to positive 1 but add to negative 2. So my answer is just y equals 1. But this is a system. I need an x value, so I'm only halfway there. So now we go to, what do we do with that? We plug the answer, or answers, back in to find the values of x, in this case. So let's go to the easier equation. Let's go to B. I have x minus y equals negative 2. Let's plug in x minus 1, y is 1, x equals negative 1. So my solution to my equation is negative 1, y is 1. So I expect when I draw these two shapes that they're gonna intersect at one place. Let's see if that's true. So if this is 1, 1, 1, 1, I have a circle with a radius of radical 2, right? Because it's r squared. So r equals the square root of 2, which is 1.4. So let's graph that. So 1.4, 1.4, 1.4, 1.4. Draw your circle. Now I'm just gonna graph the line after this. The line is x minus y is negative 2. Let's solve for y. So move the y to the right by adding y and move the 2 to the left. X plus 2 equals y. Well, what is this? This is y equals mx plus b. So I start at 2, so if this is 1, then this is 2, and I graph a slope of 1. Down 1, over 1, down 1 over 1. It's a positive slope with b is 2. So there we go, and that's exactly what I was expecting. These two graphs intersect at one place. And what is the one place? The solution is negative 1, 1. So, okay, let's go on to elimination. So we eliminate, generally, look at this problem. When we could solve for y and substitute, but we don't. If everything is squared, I definitely use elimination. So I'm going to use elimination here because there's a negative x squared and a positive x squared. If I add those together, they'll cancel. Let's do that. So negative x squared plus y equals negative 7, my a. My b is x squared plus y squared equals 9. Notice those are not like terms. Now what happens? These cancel. And I am left with y squared plus y. 9 and 7 is 2 equals 2. Let's pull the 2 over. Y squared plus y minus 2 equals 0. Now I have a trinomial that I can solve, because that's what I have to do next. Solve for the remaining variable, which is y. So let's factor it. It's an easy factor because the a is just 1. What multiplies to negative 2? But adds to positive 1. Well, if I make the larger number positive, smaller number negative, they'll multiply to a negative, but they'll add to the positive 1. So we'll get y equals 1 and y equals negative 2. Remember, we have those. Plug your answers back into to find x. So y equals 1. Let's look at it. So let's pick a. Fine. Doesn't matter. It doesn't matter which one you choose. Negative x squared plus 1 equals negative 7. I have substituted for y there. I'm just looking up here and substituting for y. So negative x squared, subtract the 1, is negative 8. X squared equals 8. Divide everything by 1. X equals positive negative square root of 8. So let's write the solutions that we have. We have two solutions. For y is 1, we came up with two solutions. So you come over here and you say, okay, y is 1, 8 could be radical 8 or negative radical 8. Let's try y equals 2, negative 2. Y equals negative 2. So looking at our second solution. Negative x squared plus y, minus 2, equals negative 7. I just substituted the y in for my equation. Add the 2 to both sides. Negative x squared equals negative 5. X squared equals 5. X equals positive and negative radical 5. Another 2 x values. So therefore, that means another 2 solutions. So when y is negative 2, notice I could have positive radical 5 as an answer or negative radical 5. So let's quickly graph this to see if that's true. Well, on first look, it's a circle and a parabola, so that looks like that's one of the answers I could have expected. So I have a circle with the center at the origin and an r equals 3, radius equals 3. So I quickly draw my circle, and then I have a parabola. Well, I need to get this into standard form. So I keep the x squared terms on the left, everything else to the right. Let's get rid of those negatives. X squared equals y plus 7. Now I'm in standard form. What is my center? My center is 0, negative 7. Let's graph it. Vertex. 0, negative 7. So this is 3, this negative 3, this is negative 7. Now, I have 4p equals 1. There's my 4p. P is 1/4. The lattice rectum is just going to be 1. This is facing upward. It's x squared, so it's up or down. P is positive, so it's up. So P itself is going to be just 1/4 in. The lattice rectum, so it's through the focus, it's just going to be 1. That's how it's a very narrow parabola. So there we go. And how many solutions do I have? I have 4. 1, 2, 3, 4. Okay? And that was what I found algebraically was confirmed graphically. Okay. So I just want to get you started on the next equation, set of equations. Solve the system algebraically. I have a circle with a center at 0, 6. So 0, 1, 2, 3, 4, 5, 6. There's my center of my circle, a radius of 4. So radius of 4, and I'm drawing down here at the bottom. So up here I have, there's my circle. All right, there's one of the equations. Then I have an ellipse with a center at 0. It's a horizontal ellipse because A is larger. It's 12 by 2. So I go to my, down here, and I say, okay, ellipse, 6 and 6 because A is 6. Did I count that right? Nope, I didn't. And then B is 2, so up 2, down 2, and there is my ellipse. So I am, with the graph, I'm expecting one solution, but I have to prove it algebraically.
Good morning, Smyrna Park.
All right, you guys do this.
Wednesday, March 16th.
I'm going to recommend you use elimination.
Stand for the Pledge of Allegiance.
So use elimination and try that one.
I pledge allegiance to the flag